On number 13, we're asked if we're investing $100 at 10% compounded monthly, how long will it be before we have $175? And then it asks about compounding continuously as well. So let's deal with monthly first. To do monthly, we're going to use our discretely compounding equation, and that is the one that looks like this. So, we know we want $175, so that's going to be our A value. We know we're putting in $100. Our interest rate is 10%, so 0.10. We're compounding monthly. We're solving for time. The first thing I'm going to do is get my exponential all by itself. Every time. That's the first step. So, this is my exponential. My exponent is only attached to what is in the parentheses. Before I do anything else, I'm going to divide both sides by 100. And then I'm also going to go ahead and put this in my calculator. 1 plus 0.10 over 12. And when I put that in my calculator, I get 1.0083. And now that my exponential is all by itself, throwing a log of both sides allows us to bring down the exponent. So, if I take the log of that other side, I got to take the log of 1.75. Again, that lets me bring my exponent down. My last step is going to be to divide to get my x all by itself. I'm going to divide both sides by 12 log of 1.0083. And remember, when you're putting this in your calculator, either use the stacked fraction or put your denominator there in parentheses. You don't want a calculator mistake to be the reason that you don't get this problem right on the test. So that gives us 5.6419 years for our time. The second part of the problem is if the compounding is continuous, how long will it be? So again, we're going to solve for time. For compounding continuously, we're going to use part. So we're going to put the same information into this equation. Again, the amount we want in our account is $175. The amount that we put in initially was $100. Our interest rate is 0.1 and our time is t. Now, don't get all excited and take the ln of both sides for your first step. Just like we divided by 100 in the last example, or in the first part of this problem, we need to divide by 100 here. If you take the ln too soon, you're going to make mistakes. It happened to a lot of you on the quiz. So, here we go. E to the 0.10t. Now that our exponential is isolated, now we can take the ln of both sides. And we're going to use ln in this problem, or in this part of this problem, because we have an e in the problem. So ln of 1.75 equals 0.10t ln of e. And again, ln of e is 1. That's why we chose to use ln on this problem. 0.1 times t times 1 still gives us 0.1. Last thing we're going to do is divide both sides by 0.1. And when you put that in your calculator, you get 5.596 years for your time. So it's not a ton faster to work with, or if you are compounding continuously, but it is faster. And again, continuously, when you're compounding continuously, it should always be faster to your goal.